All right, welcome back. Now we're going to work the next, I guess, 3 problems here. So let's get started. We have a hydraulic shear applies 2,000 pounds of force to a wedge. So applies means that is my force effort. So I'll write that no down, 2,000 pounds. It is used to shear plate steel to rough size. The shear has a 1/4 inch thick cutting blade with a 45-degree slope. So first of all, let's draw a shear. And we did a little bit different than what we typically would talk about. And I want to start here. I'm going to just a shear. And so our force effort is going to be pressing down on this guy with 2,000 pounds. Okay. Then it says that it is a 1/4 inch thick cutting blade. So the distance from here to here is going to be 0.25 inches. I'm writing that super small. And that it's 45 degrees. So we can say that this guy here, this is 45 degrees. Okay. I think that's about what we know right now. It says also, hey, make sure you note that, about a 45, 45, 90 triangle. What is the length of the slope? Now, they try to trick us a little bit right here with this problem, because remember when we were dealing with inclined planes, we need that hypotenuse. That's going to be our distance effort, okay? But in this guy, our distance effort is going to be this length here. So don't let it fool you. They're trying to fool you, but we're going to do it anyway. So it's a squared plus b squared equals c squared. So you put that in your calculator, you're going to say 0.25 squared plus 0.25 squared, and that's going to give you 0.354 inches. And then we never do anything else with that again. Just practicing, I guess, doing some Pythagorean theorem. Then it says, what is the ideal mechanical advantage of the wedge? IMA. Ideally, this year, I'm going to kill a deer. Distance effort over distance resistance. Now, remember, specifically, they give us for a wedge, they say IMA is equal to the slope perpendicular to the height over the height. Now, this is where I was telling you that if you know where to measure and what to measure, you don't need all of these formulas. Okay, so when I can just throw that guy away, I don't need it. And I can say, well, my distance effort, I know what that is. Okay, well, it's going to be, and let me just label it for you, because it's going to be my force effort is going this way. Okay, well, if I think about that, that idea of, well, this is going to split something, right? So it's going to be splitting that apart. Okay, so the when I drive this wedge in, okay, and then I split it apart, one of those is going to be my distance effort, and one of those is going to be my distance resistance. And so you can kind of think about that. Now, in this case, because it's a 45 triangle, it really doesn't matter. So when we look at this guy, it's like, oh, wait a minute, it should click to you. Well, my distance effort and my distance resistance are the same because they're both a 1/4 inch. So 0.25 over 0.25, well, what? 1. Now, so don't make that any harder than it needs to be.